Dear friends, in this class we are seeing about how the summation can be used to find distance and velocity. So, here at first we are seeing about a formula if a particle moves with a constant velocity v1 for a time interval delta t1 and v2 for a time interval, the next time interval delta t2. Then comes v3 for the next time interval delta t3, and at last we are taking velocity vn for a time interval delta t suffix n. Then according to a formula, velocity is equal to distance by time. So, you can say that distance is equal to velocity into time. So, delta d, the distance, total distance travelled, becomes v1 delta t1 plus v2 delta t2 plus v3 delta t3 plus etc. plus vn delta tn. That is equal to sigma I equals 1 to n vi delta ti. Then we will do a problem. The problem reads a bus moves with the following velocities. It is a day-to-day life problem, 4 meters per second for the first 2.5 seconds, 5 meters per second for the second 3 seconds, 3.2 meters per second for the third 2 seconds and 1.4 meters per second for the fourth 1 second. How far does the bus travel? This is our question. So, find the solution. We use the formula total distance travelled by the bus. Delta d is equal to v1 delta t1 plus v2 delta t2 plus v3 delta t3 plus etc. plus vn delta tn, where for each I is equal to 1, 2, 3 etc. up to n, vi generalizing the velocity of the bus for the time interval delta ti. Here n is equal to 4, that is there are 4 values v1 4 meters per second, delta t1 the first time interval 3.5 seconds, then v2 5 meters per second, second time interval delta t2 is equal to next second, and v3 3.2 meters per second, delta t3 equals 2 seconds, and v4 1.4 meter per second, delta t4 equals 1 second. Then what is the total distance travelled by the bus? Delta d, it is equal to v1 delta t1 plus v2 delta t2 plus v3 delta t3 plus v4 delta t4. So, the values are 4 into 2.5 plus 5 into 3 plus 3.2 into 2. That is the third velocity is 3.2, it is not 3 equals to 3.2 and 1.4 into 1. Final answer 10 plus 15 plus 6.4 plus 1.4, that is 32.8 meters. Next problem, problem number 5. Suppose that a bus is at position yi at time ti for I is equal to 0, 1, 2, 3 etc. n, and that during the time interval ti minus 1 ti, the open interval, the velocity is constant. Using a telescopic sum, confirm that the distance travelled by the bus equals the difference between final and initial position. So, here we are given a bus and it has a position yi at the time ti, and the time interval delta ti is ti minus 1 ti, the velocity is a constant. So, the velocity's formula is actually distance divided by time. So, at the time interval ti minus 1 ti, vi is equal to yi minus 1 whole divided by ti minus 1, that is equal to the difference in y, the positions delta yi, difference in time, the time interval delta ti for I equals 1, 2, 3 etc. n. So, according to our formula, the total distance travelled by the bus is delta d, it is equal to sigma I equals 1 to n vi delta ti. It is equal to vi could be written as sigma delta yi by delta ti into delta ti. So, you can see that it is equal to sigma I equals 1 to n delta yi. Delta yi means yi minus 1, so it is equal to sigma I equals 1 to n yi minus 1, and is equal to yn minus y naught, that is by telescoping sum. Thus, the distance travelled by the bus is actually yn minus y naught, that is the difference between the final and the initial position. So, thank you dear friends, we will see in the next class. Goodbye.